In section 10, we'll be looking at quadratic functions. If you remember quadratic functions, they look, when you graph them, they give us an N shape or a U shape, otherwise known as parabolas. And quadratic functions, we saw functions last section. This section, we're going to cover something again, and that is a quadratic function, what it is to be a quadratic function. If you guys remember factoring, remember we had some trinomials, we would factor quadratic expressions, right? And what that means is that it's of this form, where x has an exponent of 2, and that's the highest exponent, and then we have a bx and a c. Here, the only constraint is that this number a cannot be 0, because if that's 0, then this all gets canceled out, and we just have a linear equation, not a quadratic. That's why we want to have that a be a non-zero number. So, solving by factoring. We're going to solve quadratic equations by factoring. Notice how that our quadratic equation here is equal to 0. We're going to solve for x. We want to know what x is. And the way we're going to do that is with these 3 steps, which, like the other slides, hasn't really meant much when I put steps up unless we go over it. So let's go ahead and go over some examples. Say, for example, they were to ask you to solve for the following quadratic equation. And here we have 3x squared minus 6x equals 4x minus 3. But wait a minute, that looks nothing like what we had over here, right? These two look nothing alike. Well, not really. So we're just going to manipulate. Remember algebra, our algebra skills, we're going to have to use those time and time again in our math classes. So we're just going to go ahead and move everything to one side so that on the right hand side we can have the number 0. So how's that going to work? So first thing, we're going to subtract 4x from both sides. The reason we're going to do that is because these 4x's cancel out now. And negative 6x minus 4x, that'll give us negative 10x. So we have 3x squared minus 10x equals negative 3. After that, we're going to add 3 to both sides so that those 3's can cancel out. And we're left with 3x squared minus 10x plus 3 equals 0. Now, if you notice, it does look a lot like the quadratic equation in our definition in the green box. Right, this looks like this now. All right, now that we set our equation equal to 0, we took care of the first step. Now step 2 is going to be to factor. So just like we were factoring in, I already forgot the section, but in a previous section we were factoring, we're going to do the exact same thing here. We have 3x squared minus 10x plus 3. And if you remember, this is the way I've done it all my life and it's worked. We use trial and error to factor it, right? We want to factor it into 2 binomials that are in parentheses. Let me show you what that's going to look like. That's going to equal 3x minus 1 times x minus 3. And if you want, you can go ahead and multiply those out and verify that indeed these 2 are equal to each other. So that's step 2. We took care of step 2. We'll cross that one out. We'll cross step 1 out. All that's left is equal each factor to 0 and solve. So what are the factors? The first factor here is 3x minus 1. The second factor is x minus 3. So we're going to go ahead and set those equal to 0. 3x minus 1 equal to 0. Now to solve for x, again, just a little algebra. We're going to add 1 to both sides. That'll cancel those ones out. We're left with 3x equals 1. And all that's left to do is divide both sides by 3. So those 3's can cancel out. And we're left with x is equal to 1 over 3. Now, careful. That's one answer, right? We took care of one factor. This factor, we no longer need it. We took care of that one. We still need to do our second factor. So we have x minus 3 equals 0. Just one step will get us to the answer here. Add 3 to both sides, and we get that x is equal to 3. So those are both our answers. And with quadratic equations, you will always get two answers. All right. So just careful with that. All right. Make sure if you get one answer, you're not done yet, unless it's a repeated roots. But we'll go over that later. Now this is solving by factoring, right? So up here it says solving by factoring. What if we get a trinomial or a quadratic equation that we can't factor, or we're having a hard time factoring? That is when we come to use the quadratic formula. Now, I'm sure you've seen this before. If you already forgot, well, this is the time to relearn. Our quadratic formula, if you guys remember it, is x equals, well, that big fraction, I'm not going to say it, but it's that long fraction that will give us our answers. And what are the steps for using this formula? They're pretty similar. We're going to identify A, B, and C. Notice how our quadratic formula has A's, has B's, and has C's. Right? We want to know what that means. And what that is those numbers that are in front of x squared, in front of x, and on its own, the constant c. And then we're going to plug into the formula, simplify, and that would give us our answers. Maybe it's a little more work than factoring, but this method always works. That's what's nice about it. So again, let's look at an example. Suppose they asked us to find the x-intercepts, and all that means is to find where the parabola crosses the x-axis. They're asking us find the x-intercepts of the function y equals 4x squared minus 2x minus 4. So once again, let's go step by step. We know a is 4. Where are we getting that 4 from? That 4, remember, is coming from the number in front of x squared right here. So this is a. B, as you can guess, won't just be 2. It'll be negative 2. We're going to have to include the sign. So B there will be negative 2. And the same thing with C. C, we're going to have to include that sign there. And it'll be negative 4. All right, we have identified A, B, and C for step 1. Step 2, now we have our quadratic equation, or sorry, our quadratic formula. Now, this is not really a necessary step. This is what I call the skeleton of the quadratic formula. I tell students to write the skeleton out first. Reason being is because this negative here can mess with a lot of people. Drawing out the skeletons adds more work, but it makes sure we don't make mistakes. So this is what I call the skeleton. Parentheses are empty. That's where we're going to put in all our A, B's, and C's. We know what those are, so I'm going to go ahead and put those in. And notice, right here with this negative 2, that's B, right? That's where this is coming from. Students get confused. They see this negative right here and think, oh, well, I don't need to include the negative anymore because it's already there. That's not the case. We still have to include it. That's why the skeleton is useful a lot of the times. So, all right, let me just go ahead and clean this up a bit. So now we go ahead and simplify. Yeah, so this is plugging into the equation. This is step 2. This concludes step 2. So I'm going to cross out and out, cross 1 out. All that's left really is to simplify. So let's go ahead and calculate. First things first, a negative times a negative right here will make it a positive 2. Oh, there's one thing I haven't addressed yet, and I apologize for that. Notice in the quadratic formula, if you look at the red box, let me go ahead and clean these arrows up. If you look at the red box, notice in the formula where there's always a plus or minus here. The reason there's a plus or minus is because there's always two answers. One that's going to be with the plus and one that's going to be with the minus. All right, so, and we'll get to that. I'll show you how it works right now. Anyway, we're simplifying here to positive 2. Negative 4 times 4 times negative 4 equals positive 64, which is down here. Negative 2 squared is equal to 4. That's why we have it here. Over 8. Once again, we can simplify that. If you remember the factorization tree, here we're going to have square root of 68. If you remember the tree, you can go ahead and do that to 17. So that we have 2 plus minus 2 times the square root of 17, since we just used the factorization tree, all over 8. The last thing to simplify is notice how this 2, and this 8 are all even numbers, so they're all divisible by 2. So we'll divide them all by 2, and it becomes 1 plus minus square root of 17, because that 2 went away, over 4. Now the last step. Remember I told you there's two answers, one with the plus and one with the minus? All we're going to do is we'll divide it into 2. Our two answers are x equals 1 plus square root of 17 over 4, and the other one is 1 minus square root of 17 over 4. That's what the plus minus does there. All right. As we move on here, there's something you might need during the test. It's not used too much. We don't use it too much in math, or I shouldn't say in math, in math classes at the university. Although it is always nice to know, it is always nice to have it in our toolbox. If you remember completing the square, well, the steps go something like this, right? You're going to take a quadratic expression, and a lot of the times it's not factorable. We can't factor it, right, into nice binomials, into nice factors. So what we do a lot of times is complete the square, and we do it by following these steps. The only thing I want you to really pay attention to right now is that a has to equal 1. And we'll deal with something where a is not equal to 1, so I can show you how it is you solve that. But let me show you an example of how we complete the square. Say, for example, you're given x squared plus 6x plus 7. You can go ahead and try to factor that. If you want, go ahead and pause it. Take a minute or two to try to factor that. And you'll see that it really isn't possible. So here's what we're going to do. As step 2 tells us, we're going to add and subtract b over 2a squared. Now remember, a is this number in front, which is just 1, and b is this number 6. So this is what it's going to look like. b over 2a squared is 6 over 2 squared, which is equal to 9. So we're going to add and subtract 9 from our expression. And I put them in red so that you could see it easier. And what does that do? What that does, how we completed the square, is now try to factor this instead. If you try to factor this, it's a lot easier. It's a perfect square, actually. It becomes x plus 3 squared, and then we still have the 7 minus 9. That becomes negative 2. So the reason we complete the square is so that we're able to factor it into a square when it would otherwise be impossible to factor. So that's completing the square there. We'll go over a few more problems when we review, so you can see how that works. Get a little more practice. You do have problems in your packet you can work on. Now, we'll move on to graphing a quadratic equation. The way we graph a quadratic equation, once again, I'm going to include some steps. We want to convert it into what we call vertex form. And vertex form is up there in step 1. It looks something like this. And guess what? We're going to complete the square to be able to put it in vertex form. So we'll get practice there. And let me give you an example here. Say, for example, they want us to graph 2x squared plus 3x plus 5. Roughly, not exactly. Now, if you were to have a graph, say like this, you could make a table, x values, y values, plug in 0, 1, 2, 3, 4, so on and so forth, into these values into the equation, and you'll get out your values. And then from there, you can graph the points, yada yada, graph the function, and you're done. But that's not really what we want. It's just not what we're looking for. What we want to do is complete the square because it's a lot easier to factor once we have it in vertex form. And let me show you why. If we have this equation here, this function, we want to complete the square. And remember I told you that a always has to equal 1? Well, in this case, it's 2. So what we're going to do is factor out that 2. So what happens? It now becomes 2 parentheses and then the rest, right? X squared plus 3 over 2x plus 5 over 2. If you distribute the 2, you'll see that you'll get our original equation back. But now that we factored out the 2, we can complete the square because a is now 1 here. So again, it's b over 2a squared. So we're going to complete the square. I'm just going to show you what this is, b over 2a right here, squared. And I added it and I subtracted it, right? But now that we did that, we can complete the square. If you want to try it, you can go ahead and factor this. Go ahead and pause it. You can try it for yourself. That'll become x plus 3 over 4 squared. And then if you simplify this over here, 5 over 2 minus 9 over 16, that'll equal 31 over 8. Now, I know it looks a bit involved, especially because we're dealing with fractions here. It looks messy. But it now becomes really easy to graph this, right? Our vertex here is HK, right? If you look at the top, HK, meaning our vertex here is negative 3 over 4, comma, K, which is 31 over 8. So that's your vertex. Now, why do I say that this is a negative right here? Well, because if you look at the top, our vertex form, it has a negative originally. So if it has a positive here, that means there was another negative involved, which is right here, to make it positive. If that was confusing, think of it this way. Or I'll give you, I suppose, a shortcut. Whatever you see inside this parentheses, just flip the sign. If you see a minus 3 over 4, then this is a positive 3 over 4 for your vertex. If you have questions about that, completing the square does involve some practice and understanding. So it's, everyone asks questions with this, so please do. But in this case, our vertex is going to be negative 3 over 4, comma 31 over 8. So our graph is going to look like this. If you look at this vertex here, I put the coordinates right here, although they are a bit small. But as you can see, it is exactly those coordinates, the vertex. And then it's just a U shape going up. Why is it going up? Well, that only happens because this 2 is positive. Whatever number is a, if a is positive, then it goes up. If it's negative, then it goes down like this. All right, so this is a long lesson. We still have one more slide to go, and then we'll be done. But if you want, if you need, you can take a break. All right, it's hard to keep, paying attention for long periods of time, especially when it's something dealing with math and when it's, not so intuitive and straightforward. Last thing we're going to look at are graph transformations. And just like I've done in every other slide, I'm going to put the steps. These aren't necessarily steps. This is more like a guide. And so in other words, you can pretty much ignore these numbers. They're not steps, they're guides, right? Instead, I should have put dots here. How do we know how a graph moves? Well, if we're given, for example, y equals x squared, and we're asked to describe the transformation of this graph, what happened to it, right? What did it do? Did it move up, down? Did it reflect? Did it move to the right? Did it move to the left? Here, we just look at our guide. And there's probably ones on Google you can find that are a lot better, maybe in some textbooks. If it's inside the parentheses and it's a negative number, it moves to the right 2 units. So it's a horizontal shift to the right 2 units. And where do we get that from? Well, that tells us right here. X minus h means the graph is shifted to the right. If it was plus 2, then it'd be to the left 2 units. And then what about k? What about this number out here? Well, if this is left and right, what do you think k is going to be? Up or down, right? So that -3, this one is intuitive. Negative does mean go down. Positive does mean go up. So in this case, we have a vertical shift down 3 units. And I didn't provide a graph for this one, but let me just go ahead and graph it just to give you an idea. So in red, I'll put y equals x squared. That's going to look something like this. Oh my gosh. Let's see. Something like this. Uh-oh. All right. Something like this. Now in green, I'll put y equals x minus 2 squared minus 3, our new function. Now we move down 1, 2, 3 units, and then to the right 2 units. 1, 2. So this is our point here. That's our point there. And then from there we just, draw the parabola again. So that's our new function. Again, completing the square, transformations, all this, a bunch of information given to you just in such short amount of time. Maybe review for some of you. Others, you might be learning it for the first time. There's no problem with that, but please do ask questions and practice. All right, that concludes our quadratic equation lesson.